I get a feeling there's going to be a riot.
Assalamualaikum and very good morning to Madam Azzyati. Today we are going to conduct two experiments about the diffusion. So the first experiment's objective is about to determine the effect of temperature on the diffusion, and the second to study the rate of diffusion among two gases, which is we use ammonia gas and hydrochloric acid. So before that, I would like to introduce my group members, which is me, Muhammad Hafizuddin bin Abdullah Sani, Muhammad Azrareza bin Abdullah, and Shukor bin Muhammad. But before that, let me explain to you about the introduction of the diffusion. First of all, the theory of diffusion. As we know that the diffusion is one of several transport phenomena in nature. The movement of molecules, components through space, and it will stop after both sides reach equilibrium in terms of concentration. It results in mixing substances or mass transports without requiring bulk motion. So, for the theory of diffusion, we know that the gas of high concentration will flow to the gas that have low concentration in random molecular motion. So basically, the principle of diffusion, we have concentration gradients, which shows the shift in concentration as time increases. Second, the molar flux. The molar flux is directly proportional to concentration gradients and the diffusivity of the component. Third is velocities of components. Velocities of the components describes the movement of particles in bulk phase or individually phase. So fourth is concentration or molar densities or mole fraction. As we know that the mole fractions, we want to define the number of molecules that flow from high concentration to low concentration. Okay, for the experiments, we may proceed to Shukor bin Muhammad to conduct his experiment about the rate of diffusion between two gases, which is ammonia and hydrochloric acid. Okay.
Assalamualaikum and very good morning to Madam Azyyati who's watching this video. Please. Today I will run an experiment about diffusion of gas, ammonia and hydrochloric acid.
What we have in this experiment is a ammonia solution NH3 and hydrochloric acid solution HCl. As we can see, place a piece of cotton wool at the tube and push it into the end of the tube, and then drop a concentration of ammonia solution at the piece of cotton wool at the end of the tube. Ammonia and hydrochloric acid is a colorless gas, but when they meet, a white cloud from ammonia and hydrochloric acid will form. Now I will take a hydrochloric acid. As we can see, there are some clouds have formed. Now I will drop a concentration of hydrochloric acid at the piece of cotton wool. Place the tube horizontally as we can see now. Put the piece of cotton wool at the beginning of the tube and close it with cover. Now we have an ammonia solution at the right side and hydrochloric acid at the left side. As we can see, there are white rings have formed and it is closer to the hydrochloric acid at the end of the tube at the right side.
I have explained the procedure for the experiment, and now I want to explain a little bit about the theory. The exact time taken for the ring to form will depend, first, the dimension of the tube, second, the amount of the solution which are put on the cotton wool, and third, the temperature of the room, which is the ambient temperature. The ring is usually formed nearer the hydrochloric acid and of the tube because hydrochloric acid diffuses more slowly than ammonia. This is because hydrochloric acid has almost twice the molecular weight of ammonia, and the rate of diffusion is inversely proportional to the square root of the molecular mass of the gas. It is worth noting that the rate of diffusion is not the same as the speed is which the gas molecular travel, which is hundreds of meters per second. The gas molecule follow a zigzag pattern throughout the tube as they collide with the air molecule in the tube. The purpose of the glass tube is to eliminate air current and to see if the gas molecule will move on their own. The reaction which is taking place is the form of white ring is ammonium chloride, which were NH3 plus HCl will produce NH4Cl. That's all. Thank you.
For the second experiment, Muhammad Azrareza bin Abdullah will show you about the effect of temperature on diffusion.
Assalamualaikum warahmatullahi wabarakatuh. I am Azrareza from 3BCDB. Today I would like to conduct an experiment about the effect of temperature on diffusion. Here we use to different type of different temperature of water. This is hot water and this is cold water. I will pour a spoon of potassium manganate to each beaker. I will pour it to cold water, and the secondly I will pour it to hot water. As you can see now, after a few minutes, hot water, the entire of hot water will turn purple, and cold water you can see that it's clear at the top of cold water. Okay, as a conclusion, faster diffusion take place if the surroundings are warm. Increase in temperature means
and increase in molecular speed, or we'll call as kinetic energy. So the molecule move faster, and there will be more spontaneous spreading of the material, which means that diffusion occur. So it will increase the rate of diffusion. So the hypothesis before, the increase of temperature will increase the rate of diffusion acceptable. I think that's all from me, and thank you.